Okay, I think we will make a start because we're all busy. We have got meetings after this. So good morning, everyone, and welcome to this special seminar. And I wish to acknowledge that University of Western Australia is situated on Noongar land, and the Noongar people remain the spiritual and cultural custodians of their land and continue to practice their values, languages, beliefs, and knowledge. So today we have got many of us know Professor Xinhua He, an endowed professor at the Sichuan Agriculture University in China, and research professor at UC Davis, and adjunct professor at the School of Molecular Science here at UWA. After his PhD in University of Queensland in 2002, Xinhua worked as a postdoctoral fellow at UC Davis, University of Tokyo, again UWA here, and USDA, and associate professor at the University of Sydney and at UWA. By using C13 and 15 stable isotopes, high throughput sequencing and more, Xinhua has been studying on carbon-nitrogen cycling in plant, soil microbe system, and interplant carbon-nitrogen movement under global environmental change, basically climate change. He has published more than 270 journal papers with a H-index of 58 and 11,000 citations, and serves on editorial boards and is a member of organizing committee for the diverse international peer-reviewed journals and conferences. And Xinhua is here attending the or attended the International Wheat Congress, and I had the pleasure of listening to his some of the things which he's going to talk today. So the main topic is interactive response of wheat, faba bean cropping to elevated CO2 and mycorrhizal fungus. So China is the largest producer of faba bean in the world. Still, it is the largest producer. So please welcome Xinhua. Thank you.
It's nice to come back here, and especially you found the time to arrange a seminar or lecture, especially for Satika. You are so busy, you just come back, and we just yesterday just finished the Congress, and so a little bit late to let you guys know I'm come here. So because I don't know, I will be here, yeah, because I'm not working on the wheat for most likely more kind of forest ecosystems. So that's I asked, and then they invited me to come here to give some talk over there, and then I come here. I say, oh, so that's it. So that's okay. Okay, that's zero. So that is something like I would like to go back to China to use some free money. That is restricted. Have free money to construct this, so spend $1 million. So something like this. So this is on the campus of the Southwest University in Chongqing. If you have been over there, it's a big city and something like that. Anyway, so and so here we should so the title is like this, but we should consider the elevated carbon dioxide and the mycorrhizal, and also the cropping systems. So this is over there. This is canola. Yeah, this is something you say faba bean and wheat. So here, oh, that's okay, because we learn each other. But I have to, something like that. So we should consider first is the wheat, or what is important for wheat and faba bean. And also there are monotype cropping and intercropping. And also we have to consider the carbon dioxide concentrations around the world. The variation is so different, but the IPCC just give us one number, 400, 420. Actually, not true. Okay, we're suing. So, and then arbuscular mycorrhizal, say this is beneficial arbuscular for most of the crop, cereals, the grasses in agriculture, but because the plowing and the fertilization and the irrigation, so they destroy the hyphae, fields, so we can do that large scales in the agriculture, but most likely we do it in the ports, okay, the laboratory. So, and then we have to consider these three guys together, and the amicus, they should be friends or the foe, something like that. Okay, then we have to have the facility. So they have lots of facility, but now we have, we just decided by our own, and then to have this one, or show you more, and then results and conclusions. So this is most likely we have lots of papers, I have dozens of papers published so far. Only for monocropping, nothing for intercropping, still on the way. So probably I will not to give too much of that, okay? Because you can check the publications, something like that. But the future research considerations, something like that, especially with the temperature already during the conference, the Congress, and the presider, you said, the chairman said, you have to consider, oh, that is good for the temperature because greenhouse effects and then the carbon dioxide increase, then will be increase the temperature. So we should consider all of this since there's too many factors you should consider. Okay. So the first one is the wheat production, and then you can say wheat is a food crop for 1/3 of the global population, especially for the Western countries, not for the Southeast Asia, especially in China. But it's half in the north, they eat the wheat, flours, and in the south is most like rice. So China is the largest wheat producing country around the world, and also nitrogen use efficiency is only 1/3 of percentage, 30 to 35%. It's much higher now. Used to be maybe around 20, something like 25. But in Australia and in America, it's something like 50 or 60%. Because over there the input is so excessive, so it's too much. Anyway, and especially I would like to tell you the truth, and because the scientists, or even some scientists or the extension people go to the countryside, they ask the farmers, so how much nitrogen you use? They say 100 kilos. But actually that is ammonia, that is maybe most likely is the urea, but it's only half of that. You have to calculate it back. You have 2 times or maybe 4 times more than people tell you. You have to calculate it. So they said it's 1,000 kilos. I never believe that. But anyway, you don't know that because if you want to consider it for the farmers in China, they speak Chinese to you, you can't understand. Okay. Anyway, there's a faba bean. Faba beans also around most likely in the Middle East and in Asia. We also have some in Australia, but it's not less. Anyway, this is very important protein. Plant protein for the countryside people. China is the largest, as Steve said before, the largest producer for faba bean as well, especially in northwest in China. And also faba beans can fix nitrogen and move the nitrogen in the ground to adjacent plants. Or also they are in populations, so they can transfer each other. So that is, but anyway, these two guys, but most likely they are grew individually, not come together, because especially in the Western countries, because they have a big machine, it's difficult to harvesting, and also arranging the timing and the season, so a little bit difficult. But anyway, that is this is a long history, non-traditional cropping system in China. So that is the crops. And then we have the carbon dioxide. We have this one. I have said this before. This only maybe something like 60, 70 years ago. It's only 300, but now it's jumping to year 2025, 2015. It's jumped to 400. So this is a big event over there. But anyway, so here is the daily average day. It's around 425 now. So this is from Hawaii, the monitor, this around the world. They have most likely from the pole and to Arctic and to Antarctic area, and also in Hawaii. So that is, they tell you this is a number. to 420 something like that. But it tell you one number. How about it now? How about it in the morning? How about it in the night? So it's totally different. So we can say, but this one associated with the temperature increase of 1.5, something like that. So far, but the way the FAO and also the IPCC, the UN has set it up for 1 point in the next 30 years, something like that. Yeah. But anyway, so we have to develop in the facility to start this carbon dioxide increase effects or fertilization effects on crop and growth or performance. So here is one at the Western, now it's called the Western Sydney University. Used to be it's called the University of Western Sydney. And then I went over there, but actually this closed chamber actually is shifted from Sweden. They used this before, and the first ecosystem I don't want to use anymore. Then the people from the Western Sydney University to move that one to here to set it up. So that is, but actually they have the, this is the open chamber, so you put the carbon dioxide in, but they were loose, so they were linking, so and leak. So it's a little bit hard to control. This one is good control the carbon dioxide, but it's harder to control the temperature because they are increase the temperature. So this one is good, and this is University of what? Western Sydney University. They change the name always. Okay, but that one is eucalyptus. This is good. They published. So far, they have lots of input outputs. They just published one paper in Nature this year and last year, 2 years ago, and in Science, and from here. Yeah, well, the guy moved to Zhejiang University in China. So that is the free air carbon dioxide enrichment called the phase, and here is the USD soil phase. We have one in in Victoria and and in Victoria, and also one in Tasmania. I think the Tasmania one is not in operation because the guy in Victoria is actually is a master student from Georgia Stewart, my PhD supervisor. So I know him, Roger Armstrong. So he's the manager of the Victoria facility over there. So that is, but there is lots of disadvantages and advantages. So today I have time to give a little more. So this is, you can control the closed chamber. I said that before, this will increase the temperature. It's difficult to control this, like the fog on your car screen, especially in Tasmania, but here in Western Australia. So, so that's a little bit harder. But this one is because they can only short time. But this one is wrong. Is very cost, yeah. So that is something like harder to find the wrong funds. Maybe CDK you can do that. Not for me. Okay. But anyway, so that is used to be that is Jiang Harry over there, and. So Jiang is the mycorrhizal guy over there, passed away. Yeah, you know. Now is Ying Anderson. He's managing over there. So anyway, so that one is the higher temperature and the humidity is also over there. So, okay. So and then but this one, the wind, because the air. So if you have big air, the carbon dioxide is difficult to control the concentrations over there. Yeah. So. Anyway, so this one is possible to get the high, but how high is? The people always say it's double. The double is goes to 50 or to 100 years later, so it's a little bit harder. I think we should be cut down, and we recently maybe 15, 30 years is our generation. Not for the slow generations later on. We can't say that. Okay. But anyway, so this small scale, and anyway, so I have lots of. But anyway, the phase is good. but it's, the running cost is so high, so it's difficult. We have only two. One is in rice in Japan, and the one is in China in Nanjing Institute of Soil Science. So this is only available for rice, but any other cereal, including soybean, wheat, and barley, and something like that around the world, and also in Europe. So that is, so we say, I have said that before, this is one number I just give to you, but actually since 1990s, the people already monitored the carbon dioxide is different. Why? Because, you know, when sun is coming, and then the photosynthesis, the crops, especially in the Philippines, they will absorb and take up the carbon dioxide and then they will decrease. And during the night, they also have the photorespiration, and they release carbon dioxide at the same time. And also during nighttime, they have the soil respiration, including the roots, including the soil itself, and including the biological respiration, fungi and the bacteria, something like that. So that's a increase of. And also nighttime there is low sunlight, the plants stop the photosynthesis, so the carbon dioxide is increased. So you can say here in the nighttime they are much higher, and here in the daytime is much lower. So that is the situation. And then in Japan it's also like a same situation. So it's like here is something like this. So they have the 50 or even the first system they can have 100 ppm more than that. So this is in Australia. This is just 20 years ago, and you can see here Australia a little bit higher of the carbon dioxide, and they have like this. So here is 500 or something like that. But we have the several years of the monitor of this. In Chongqing, it's like this in Southwest University campuses. So it's like here is 460, this is 440, something like that. So this is totally different. So I think it's 95% to 99% of the carbon dioxide elevation experiment is just one number. The daytime and the nighttime is the same. But we have the situation here, we have to match up with this. Otherwise, results, even you publish, I think it's 50 or 100 science or nature paper. That is not true. For my opinion, you have to match up the real situation in the fields. Okay. So, but we do, also you can see here. So this is daytime and this nighttime, and we have the monitor of here. So you can see this is totally different. So here is like this one. So ambient is 410 to 460, and the daytime is 50 to 50, or we increased that one to here, 1/3 of increase. So we can have the experiment to increase. And also for nighttime, we keep the same situation. For here is the daytime is the same, but here is nighttime is the same. So, but the increase is daytime, and here is increase at the nighttime. So according to this one, we increase 30% of this. It's only for 30% of increase. We have one facility at the greenhouse. So I think maybe next time if you want to do experiment, you have to, what you have to, maybe you consider use this experimentation is better, okay? And this one is the daytime and the nighttime. You put this both them increase at this 550 and 610 ppm. So that is the situation. And then we go to here. You can see the same, like this is, that is daily, this is weekly. So we have the yearly as well. So this is all the, so here is the situation, the temperature is changing, the variation, and then the humidity variation. But we have the facility to control, use the air conditioning. Nowadays we have the electronics like the AI. It's much easier. My students is only use the Wi-Fi. Their dormitory, they can control the things. So that is the situation. So then we goes to the mycorrhizal. So this is probably already know from market. I did this school before, and just sit down the botany and the next door of my office. So that is the situation. Okay, you want to come? You will come. So that is the interface of this. If you probably not know. And anyway, so this arbuscular mycorrhiza, so this is 70% of the crops and grasses have this one associated with arbuscular mycorrhiza. So far they have maybe 300 species, something like that. They have new updated. But for ectomycorrhiza, mostly I worked in here, but it's only 2% of the plants, but they have the 6,000 of fungi. So that is much more. So that's the situation. But anyway, plants fix carbon dioxide through photosynthesis, but limited by soil resources. And then the fungi can extract nutrients and water from the soil, but cannot fix carbon dioxide. So they both together, they are working together, and then 20% of something like that. Some people say there is more, and some people say less, and generally it's like that. And then enhance plant growth. But sometimes, especially during the very young seedling stages, they can be parasitic because they consume the carbon. Nowadays, the carbon is very fashion. Used to be our soil science, maybe the agronomy. Carbon is only for photosynthesis, not for below ground. But nowadays, it's become the what they call the carbon peak or carbon neutrality. It's very fashion nowadays. Okay. Anyway, and so the AMF fungi can facilitate the community or population and system stability as well. So you can see here, so this is a nitrogen fixation plant. You can see here is like the alfalfa, and here is the crops and the wheat or barley, something like that. So you can see the carbon is from here. You can see the mycorrhizal fungi and the hypheninkins, and here they have the nodulination. It's like the people have come here, they don't know the casheurilla. I say, oh, this is nitrogen fixation, not leguminous. Nitrogen fixation is bifrankia. So the people knows from Australia native plants. So here is the moo. Something like you need the nitrogen over there, and the carbon from here they can shift. And then you can interplant nitrogen transfer, or carbon transfer is most likely I have to do this before for something like 30 years. So this is mostly of my parts, and especially for forest ecosystems. So they have the interactions of carbon and nitrogen in this system, the pairs of nitrogen fixation and the non-nitrogen fixation plants. And so you can see here, this is wheat with soybean. So both are C3 plants. But it's different with nitrogen fixed capacity, and this is faba bean with wheat, and here is tobacco with peanut, and especially in Shandong province, in Qingdao, that area, they have because there is an institute of peanut institute in China, and also they have tobacco. Tobacco is mostly important in Yunnan province. So they have this system over there, so they are good, work together. And also they have maize and soybean. This is most likely in Sichuan and also in South, in North China plain, and also in Northeast China. They have big plantation over there. So have some, especially for Australia, they have the forest ecosystems. You have the eucalyptus and you have the casheurilla. So this is good. They have, because they have nitrogen fixation plants, are also non-nitrogen fixation plants. Although it's by bifrankia, it's not by bacteria. So this is good. You have to shift. You have to study off this. I have done some work here before, so that is some situation. But anyway, so they also have some more complicated cropping system as well. They have the vegetables. They have the canolas. They have the faba bean. They have wheat here. So they have deep. Many of this. This is just in the Southwest University campuses. So just near my glass chamber. Yeah. Okay. So they have different. So this is a good system as well. So we have to study the three guys together. Yeah. Anyway, then we will So we have set as background information before. So if this is works, so we have to consider this now, because most of the studies have only considered the only daytime carbon dioxide increase, and the nighttime also monocropping or cultivation, not intercropping, and then you have particularly they are not doing with the electrification or non-electrification plants or with the mycorrhizal inoculation. And also, so the big question is how artificially we have to construct a facility, stimulate the field daytime and or nighttime, in which the carbon dioxide AMF could be interacting affect the plant performance or major physiological characteristics, okay, under this system. Anyone, if you, so I have not considered the time very good, and anytime if you have something to do, you can go. Okay. Oh, sorry, I have to speak up. Yeah, okay. And then we have said this is for this one. We have already said this before. This is ambient and daytime. What is daytime? And then we have set up for the nighttime and also for the whole time. So that is, we have the experiment design. We have the random and put the plants in the pots and over there, and then is with or without AMF fungi. Fungus inoculation and the cropping is the soil or the two crops together, and then we have this one for we have this one for this one, 1, 2, 3, 4, and then we have the pots for this, and then we have this looks like. So they have this before the harvesting, the just flowering, and this is during the harvesting time. So you have here, there's a big, there's a tourist spot, and here is a big fire over there, and 2 years ago. And so this is the control, this is the carbon dioxide control, and use the solution, and then absorbing this. It's a little bit harder to control this guy, but anyway, afterwards we change it to this. So we change it to the cylinder for use the gas. So this is much easier, but this is the problem with the policeman. They always come to check it, so how many you can use, but only allow you use at most 3. So we have to shift here, and then this is costly because you have to transportation to ask the people to shift it to you. So now they just ask what they can. They register me and then they ask me to go to police office to say, when you can't do that, you can't put too much bottles over there. So this is a big problem. So we have this control, and they have this and the electronics. So you have to say this is something like the light intensity and the humidity and also carbon dioxide concentrations and temperature as well. So that is good. And then you can see here we have the air conditioning here. So we have the transmitters and the all of the sense stuff and to control them. So that is good. So we have this one. So we have also have this with soybean and with maize because they have different carbon signature of carbon 13. So we can track them. The carbon and also photosynthesis changes, something like that. So this is one work done by students from Afghanistan. Now he's a vice chancellor in research at the Afghanistan Agriculture University. It's good for him. So this we also done something work with mulberry. So we have one I say over there is something like that grew where, but it used to be very good. Laboratory and the soil science over there. And we have something like this, because why I put this one here? Because it's so important in Chongqing, in Sichuan province. And the national key laboratory is over there on Maribara and silkworms. And that is one of the biggest laboratory in the world. So because over there is silk so important. Circuit industry is so important. So we have this one, we have this, and to compare with this, and so also labeling nitrogen 15 or also carbon dioxide 13. You can use the gas. The gas is very costly with 10,000 bucks, Chinese bucks for one bottle. Okay. Anyway, so we have the publications over there. So something like this is I have listed here. So we need to say this is most likely we published on soil science. It's not on plant science. We have something, but here is soil microbial communities related to ammonia oxidation, and also nitrogen related to soil bacterial community, and also the oxidative defense, and also the physically not strongly carbon dioxide response or slowly response. They have the variations over there, and also the mercury accumulation, and also soil balance over there, and also all of these things and the plant science, and also plant growth and the leaf quantity, because the leaf quantity is so important to fill the circle worms. Otherwise, your circle, the quantity of a circle is different. So if you have the good nitrogen and the phosphates and the zinc and also iron in the leaves, the circle worms grow very well. Okay, so that is for this one, and also this is anyway USDA and the cited this, and also this two they cited together, and they're also doing some glominin related to soil protein, but this one is now is unfortunately is very not good for the SPB for soil biology and the biochemistry, and also the FBS, the Journal of the International Soil Society, the fertility and biology and the fertility of soils. They are not accepted to review the GRSP work anymore. But anyway, the two guys, the two editor in chief who went to Southwestern University in China. We have the big conference with I asked all the major soil science chief and editors to come to China and to give the seminars. They said, wow, BFS and the SPB do not review this, because they said you have to use the antibodies. They said this is just soil related flow study. What is it? I told them this is so difficult because I know the USDA already developed the antibodies, but how can you use it? It's like our COVID-19. So this is very hard. And then also we have this one. Wang Feng have been here and Gao Jiwen, and they have been here and published one paper in New Phytologist. Yeah. So this is we have something like this. So this is Hans over there said it's good. The good over there to say the facility. Good. And anyway, so that is why I said I always say like this. I do not the people do not interested in the results. So you can see the figures and something like that. So I said I think like the Chinese way I said it's the same situation with the English, but I don't know this is correct expression. So to give a fish or to teach you how to fish. So this is my almost offer all of these things together. So that is. So now we shift to the results. So I give some mostly like this biomass production, not all of them. Yeah, okay. So that's it. So this is like this. We have this one. We have the root arbuscular mycorrhization. So what is the effects of carbon dioxide increase and also inoculation? So here you can say this is lower. So ambient. And carbon dioxide is lower, but here is higher, because I just use I didn't put the sparse in. Okay, but anyway, this is the situation. We published this is just in text in the paper, not use the figure. So the situation is if you have you double the increase the carbon dioxide during the daytime and the nighttime together, so they have higher mycorrhizal colonization. So that is something like it's reasonable, but here is why not? I still can't figure it out. Why late time still mycorrhiza is developing well? Because there is no carbohydrates from the above ground to below ground. Why? I don't know. Maybe it's sugar. Like the guy did this before. Now they use some other sugars, some other carbohydrates, especially from the Chinese Academy of Science. They published Tao in Shanghai. They published lots of papers in Cell and in Nature in Science. I don't know. But anyway. So now this is, so this one, but anyway, so that is loculation. The biomass loculation is like a situation, and anyway, the arbuscular the relocated one, the arbuscular mycorrhization is much better here. So the higher so loculus and the nitrogen fixation for the faba bean, that is good. So here we have something like the effects of carbon dioxide and the mycorrhization on photosynthesis rate. So you can see here this is on the x-axis. So this A is so this is ambient. The day is daytime. The N is nighttime. This is double, and the daytime and the nighttime carbon dioxide increase. So this is photosynthesis. So this is only for weight. So you can see here. So from the between the carbon dioxide treatments, you can see here is this one. The double the daytime and the nighttime increase of carbon dioxide greater photosynthesis. They are greater than daytime and then greater than nighttime, and this one is equals almost like this. So, but between the arbuscular mycorrhiza and the non-arbuscular mycorrhiza located associated plants. So the photosynthesis is much higher in the AM plants. So you can see this is the gray bar, the black bar. So it's much higher than this. So, but here is most likely here is so lower. Even this one is lower than the ambient because nighttime there is low carbohydrates input or translocation from the above ground to below ground. So here is the stomatal conductance. So it's almost like the same situation, but it's a shift in the pattern. It's like here. So this one is ambient is higher, and this one is higher. Why? Because the temperature and also the humidity. I think this because it's mostly like the pore, the opening, the closing, so it's much different with that. So this is most likely you have the more carbon dioxide because they have the saturation, and the carbon dioxide saturation will affect of this. That is most important because they are close. So that's the situation. So the same situation for this, between the mycorrhiza plants and this. So the mycorrhiza plants still have the higher stomatic conductance. So like this. So here is the intercellular carbon dioxide concentrations. It's almost between the carbon dioxide treatments. This is like the daytime and nighttime increases and greater than daytime and greater than nighttime and greater than for both AM and non-AM weight. So if we take this, so my students is always like, if we take this way out, this is much easier because most of the people, 99% of the publications just use this tool. I say, okay, when they're doing the PhD defense and the postdoc defense as well, cut this off. I say, it's too many stuff, difficult to explain. I say, that's right. When the beginning, we submitted this manuscript to the journal, and it's called Frontiers in Plant Science. And then they argued with me, why you needed to use this tool. I said, this is actually right. There is no saturation. You can only increase daytime or you can only increase the nighttime. But how can we compare with this? Because it used to be, you say, oh, this is double the same situation, just one number of the carbon dioxide concentration. But now we have to use this one to subtract this one, we can get this one. And then we subtract this one, we can get this one if they are match. So this is much of like the ecosystems is a reduction box, reduction, you get the results, something like that. So this is the situation. But anyway, so between this one is still like this, they also like the greater under the mycorrhizal plants is greater than non-mycorrhizal plants at the ambient and also daytime and nighttime, but here is lower. So because I think why? Because they both they give the feeding on the carbon dioxide to them. They can't use it anymore. Yeah. So here is transpiration. The transpiration is almost like the pattern with the stomatoconductance, because they are associated with the jolt, with the humidity, and also with the carbon dioxide concentrations. So that is most likely is the same pattern with the conductance. So that is the situation like here. So we have the shoots, the biomass production. So here is much maybe a little bit either. So like this is roots. So something like that. Here is, you can say here, so this is the nighttime. So the non-mycorrhizal plants have the higher shoot biomass production, but here is the shoot is almost the same. There's no changes. So that is the situation. So the total is like this. So if you put this together, shoot plus root, the total is like, so it's much, only problem is here. So the problem is we still figured out, I think is still have the saturation of the carbon dioxide over there. So the ambient is better. And here, because the mycorrhizal development, they will consume the carbon dioxide. That is the only, I can imagine that is only the reason. Yeah, okay. So that is the situation. And here is the same like the biomass faba bean, but faba bean is different. Faba bean is almost they are here. Yep, they are here. So their ambient is much higher here. So here is daytime because they fix nitrogen. So because they fix nitrogen, then they have the carbon dioxide that can match each up because they can provide the nitrogen. Then also this guy provided the carbon dioxide, so they can increase. But anyway, so that is the situation I have can say. So faba bean is anyway is different from the pattern. It's only for the weight. Weight is like the nighttime. The higher ambient is higher. But here is the faba bean is if you inoculation. Some people say that that's right because nitrogen fixation can improve the mycorrhization, or mycorrhization can improve nitrogen fixation. So they are both mutual beneficial. So that is the situation. But anyway, so this is biomass production. This is for faba bean as well. So here is most likely we want to, most likely practically speaking, so most likely we would like to have it here. So we have the mycorrhization, we have the nodulation, so we have this one is much higher than ambient. That is our aim. So our objective is for the future, maybe 30 years, something like that. So that is good. But I don't know. Anyway, this is, you can delete it out, but you can compare with here, and then you can see here. So that is much better. So this is good. And then you can say here is total arbuscular mycorrhizal. I said that before, but that one is, this one is for the, between the carbon dioxide treatments. So you increase the carbon dioxide, you get more, and you inoculate the mycorrhiza, and you put the mycorrhiza fungi in, you get more productivity. So that is. And then, so this is for intercropping. So the intercropping, the faba bean, the shift bank over there. So if you intercropping with the weight, they come back. So I don't know why. Maybe the weight gives something to faba bean. So faba bean gives something to weight, like the guy he come here visit UWA Long Li. He's
published quite briefly.
yeah, EMP, yeah, PNS with Hans, yeah. So that is the situation explained here. So we can explain, use this figure to explain his PNFS results. Anyway, so that is the situation. But anyway, here, so this is not good. It's still not good, but if we can even under the lifetime, they can improve. They can get some more. So even lifetime, if they have the accumulation of soil respiration, carbon dioxide can reabsorb by the plants. That's good. So if you use the cover, sorry about it. And in the potting experiment is okay, I think. But the hair is good. Anyway, but this one is better than this one. Yeah. Anyway. So that is something like take away. I can't. I said that before. I cannot take more of these publications, all of the, especially for soil bacterial communities changes. They have lots of stuff, and also with archaea or AOB and AOA stuff with the oxidative ammonia, oxidative soil bacterial communities, and also nitrogen-related soil communities like the, some enzyme activities. I think most of that is for, they have not published before. Yeah. So that is something like we have the host species, because that depends on the nitrogen fixation plants or non-nitrogen fixation plants. This is easily understandable. This is a nitrogen demanding perspective. Yeah. And also cropping management. So if you glue them together, they have something like. But I know the Chinese. There is a Chinese old saying, say what is called 男女搭配，干活不累. That means you have a couple with female and male. They work very in good condition and very beneficial to each other. Something like that. So that is you have to have the management with. We have something recently published 2 papers with nitrogen fixation. That's different. You have to put it on nitrogen fixation and 100 kilograms of urea per hectare. They have increased. Have some change. Yeah. Okay, so that is future stuff is for only for temperature. So temperature is increased, so we have to do something with that. So thanks a lot for that. So that is all I have. So special issue you can do something, and then this is my students and postdocs. Okay, thanks a lot.
Thank you.
So thank you for time.
Thank you for that very interesting talk. So this is the second time I'm listening, so now I understand much better.
Yeah.
So questions, we have to finish 10:30, but others can continue.
Yeah.
But any questions?
Yes,
yeah. Jain.
So unelevated CO2, the leaf stomata conductance is significantly reduced compared to the ambient CO2. Does that mean because there is less stomata density, or the pore size has been changed?
Sorry about good question, but we didn't say that. We didn't do some more details. We just used the Leica machine to do this data. We didn't do that. So that is a good question. I think we have to check it. Even we just published one paper in the Science of Total Environment about the C3 and C4 plants, graphenically, globally distribution about that sense. They have the leaf traits, leaf characteristics. They have the density. Also, they have the size. That's most important.
But
yeah,
you're talking about both. There is no difference. It's the wheat plant, right?
Yeah, yes.
The only thing you have changed is that you have increased the CO2. So the question is that the stomatal number and things are the same. It is the same wheat plant.
Yeah.
So it has to be to do with the closure of the stomata. So we have done work. One of my students did work, and we get higher photosynthesis in C3 plants. So it could be to do with light. I'm not sure. So this is an ambient.
Yeah.
Okay.
Yeah.
So that's your conductance. So the whole decrease in stomatal conductance is a mystery. It should not be. Number is the same. Size is the same because it's the same plant. Only thing you're doing is that perhaps, I don't know, the temperature is another thing, because if you increase the CO2, if the temperature is not increased, then may not be effective as well. So there are a few things you need to think about. So that's a good question.
Yeah.
So in our case, what we did was, we had ambient CO2, elevated CO2, high temperature, and water stress. So and that's published in Global Change Biology,
Yeah.
one of my students,
Mm.
and was done in the field.
Mm-hmm.
Yeah, because I think it also showed the intercellular CO2 level is kind of different between those treatments.
Yeah, yes. Yeah, because this one is increased in daytime, not only in daytime, not in nighttime.
I
So-
know, but you should get more photosynthesis. The stomata should be opening with
Yeah.
the high CO2, but why it is decreased, that's the question.
Yeah. But anyway, we should. Yeah.
Any other questions, Lynn?
Yes, thank you
Yeah.
for your presentation.
Yeah.
It shows how complicated
Yeah.
the world is in the ground. So thank you for that. Just a simple question. Do you think China is very interested in intercropping? Do you think we're moving into that space a little bit more?
Yeah, they have the big, yeah, they have, Longli has big project for 20 millions and finished the one, and now they have another 20 millions to that, to expand of the system to, now they have most of the, that's why we want to, you didn't go, you should go. Hans went to the Dali, yeah.
I just came back from Northwest. So to answer your question, a couple of papers we've done, what we call strip cropping. So what we'll have is that 3 or 4 rows of maize, then comes the soybean. The issue is that the Northwest of China, winter wheat, summer maize, or winter wheat, spring maize is wall to wall, which is not sustainable because of the huge amount of nitrogen. So there is, as you said, it's increasing emphasis on strip cropping, intercropping, mixed cropping, but still the mechanical harvesting is possible. You plant your maize, your soybean, or you plant your peas,
Maize.
and then maize comes because it's a spring, and the maize comes in. So that system is now very much promoted.
Yeah.
We had a paper just published in Nature Communication on whole carbon storage, water use, greenhouse gas emission in that system compared with the winter wheat, summer maize. Huge amount of nitrogen.
Yeah. We had 5 days international symposium about the intercroppings.
Yeah.
Just 1 month ago, Hans went over there.
But in the traditional intercropping, it is bad because they're harvesting and things like that. Now what we call the strip cropping. So you got the strip, you showed that photo.
Yeah.
You got the cereal, you got the legume, so you still can do the operation,
Yeah.
weed control, planting by
They're,
mechanically.
they're developing the small machine, they call it.
Yeah.
Small
Yes,
machine.
Who is next person? Yeah.
Okay. Thanks, Lee. Yeah.
I'm just curious,
Mm.
because elevated CO2, the effect of elevated CO2 on carbon cycling,
Mhm.
especially in the rhizosphere, is actually very popular.
Mhm.
So in your group, based on your system, it's actually monocropping and intercropping,
Mhm.
and 2 species and not harm elevated CO2. So that's actually very interesting for carbon cycling stories.
Yeah.
Is any students in your group have worked on that space?
Yes, we have. You check it. I leave the slides for you. Anywhere I went over there, anywhere I give you a talk, I leave the slides. Free use. So you can check the publication. We have published some of that, but we still do something. We still do something like we use the carbon 13 and also M15 to track it, and
Yeah,
we,
that's where
yeah, yeah.
to the
We-
rhizosphere primary.
yeah, we would like to apply the SIPs,
Yeah.
and also we would like to apply the lanosyms.
Yeah, yeah.
Yeah, and we have the machine here, but we have you have 2 machines here.
Oh, yeah. We
I
have
have, yeah, I have always give a seminar about the lanosyms, about the plant and soil and the microbial systems. Yeah.
John?
Yeah.
I
Ja-
apologise for coming.
That's all right.
I
Yeah.
obviously got
Yeah, most of
my
that.
knowledge wrong.
Welcome.
But the AMF, it appears from the overheads that I saw that in every case, positive AMF is superior to non-AMF. Now, my question, and I'm going to, I mightn't get out of here alive when I say it. but we have to investigate the management practices that are antifungal, because, and the one that comes to mind, dare I say it, is glyphosate, because it is well recognised that it is particularly active against arbuscular mycorrhizal fungi, and that there's only work being done on looking at that and other management practices that suppress or totally inhibit AMF.
Okay. I think me is the expert here, and then and there used to be the vice chancellor is here. Okay, there is a long history about the arbuscular mycorrhiza work at the UWA. Now I can tell you, the Lanzhou University just published one paper about the further larger scale of use of arbuscular mycorrhiza inoculations to the maize and the wheat ecosystem. And I think it's published on the Science of Territorial Environment. Okay, just 1.5 months, 2 months ago. Okay, anyway, and they are online, and also there is a big, larger scale of arbuscular mycorrhiza inoculation used in Europe. It's by Master One. That is a little part from now it's in Switzerland and in Sweden. Yeah. Anyway, the larger experiment from since last 3 years, after the meeting from Canada in Rhizosphere 5, now we have shifted to Rhizosphere 6 next year to UK. So they have larger scales of these things to do. But the management is so important, because if you want to keep the mycorrhiza active, you have to do something with the conservation, not tillage. The tillage will destroy the hyphae.
The question is whether there is any evidence with you glyphosate application, which is the Roundup herbicide, is it suppressing or not? That is the question. Lynn, do you have any evidence?
We haven't worked on this.
Yeah, but I think Zed and Zachariah has been doing some work on that, some of that, but I don't know.
No, yeah. You check the Science Total of Environment 2 months ago, maybe just this month. Anyway, they have used the pesticides. There is one treatment use pesticides or non-pesticides, the large scale of application in the field. Yeah.
I'd like to also add that glyphosate's very active on rhizobia also.
That is different, because this is fungi, that is bacteria.
But our evidence in the legumes rotation, there is no significant reduction in rhizobial in legumes, whether it is chickpea, faba bean, wheat rotation. The right use of herbicides haven't shown any reduction in nodulation and nitrogen fixation. All Australian, because we have been doing the lupin work. We have been doing lupins for a long time. Lupin wheat rotation, faba bean wheat rotation, chickpea rotation. But in some soils where there is marginal pH, etc., there may be an interaction. But nodulation has been safe as long as you use the same herbicide.
Yeah, and
the main one is the sulfonyl urea herbicide, which you use in wheat phase, and if it is light and the residual effect, depending upon the soil carbon, that can affect the legume. They simply prune your root, they look yellow, they don't nodulate. That is from sulfonyl urea left over from the previous wheat crop.